This is in for repair. This is a Philco Predicta. I believe this is the Pedestal model. And a little bit of an interesting story behind this. The gentleman that brought me this for repair had been looking for one of these for quite some time, and basically nothing was turning up on the West Coast for him, so he ended up purchasing this from someone who had it for sale on the, I guess, the East Coast, and he paid about $1,000 for this, and then he had to have it shipped, which I should have asked who shipped it, because there's not many carriers anymore that will ship televisions. Now the seller told him this was restored and working, and he got it, and he apparently can't get it to work. He purchased the modulator and VCR or whatever, and he can't get any raster or anything like that. So it's been plugged in and turned on, you know, several times, so there's no point doing a slow power up of it. He said all it does is just buzzes and a little bit of hum from the speaker, but no actual light from the CRT. So what we're going to do is, I think what I'll do first of all, since he has been using it, and since apparently it was partially restored or restored into good working order, I think what I'll do is I'll just try and figure out how to open this up, and we'll get a good look at the inside. I asked him if he requested a picture from the seller of it working with a picture on it, and he said no. And I was like, well, it's a little bit risky to take someone's word for something these days, especially for that kind of money. So let's try and get it open and have a look at the inside. I'm always curious to see. I think most of you are familiar with my slogan for Philco, which is all style and no substance. Okay, here's having a look at the inside. Let's see, do we have... You have something with a model number here on it. Remember the advice I gave to those of you who are interested in restoring old TVs, and it doesn't matter if it's a TV or a car or anything like that. Before you pull out the test equipment, just open it up and stare at it for 15 or 20 minutes and get familiar with it. And it looks like I should get a pointer so we can point some stuff out. Well, for a restore job, they've used the most original looking components that I think I've ever seen. fact, it looks like they even took the time to put the original dust back in. So, let's see, what do we have here? We have bumblebee, 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 paper, couplet, or couplet, however you want to say it. I think that's a bumblebee right there. Couplet, couplet, got another couplet right there. These things drift on Philco. I'm sure you guys have watched B. Anderson TV's thorough restore of these things. Here's another bumblebee, Black Beauty. I don't know what this is. What is this thing? I'll have to look into that later. It's got one of those in it. Those like to explode. This must be the vertical down here. We got a bumblebee there, a bumblebee there, a bumblebee right there. We got a waxy here, a waxy here, a couple wax caps there and there. One of these sand resistors. I know that these I've worked on a few of these Predictas before. I know that, I think this is for the filaments, but sections of this will go open. It's got a thermistor like a CL90. This thing is all original. There hasn't been anything done to this at all. These crappy resistors that drift. Just the, oh, there's another melted wax cap down there. Just the cheapest components that they could possibly source. It's a nice speaker. I bet that would sound rather nice. This tube looks like it's got quite a few hours on it. Pretty brown. Let's see if we could get the flyback cage open. Let's see. Well, definitely crusty, definitely got some hours on it. Now this does not mean it's bad by any stretch. In fact, I would probably assume that this is probably okay. Assume. It's not saying one way or another, but I've seen this type of thing before. I mean, it actually looks like it's burnt. It looks like there's been a fire on the bottom of the can here. Look, and there's wax back here. But the visual thing there does not mean that that's bad. You just wouldn't want to use that in a damp environment without drying it out and resealing it back up. I believe this is a fusible link right here. That even looks original. Although I don't know, it's not pushed in the socket all the way. That's branded Philco. These are all branded Philco. What is that one right there? That's Philco too. Well, I would have to say that seeing the condition of this, I would be hard pressed to believe that this worked ever. Well, not ever, but ever in the past couple decades. If this was an RCA or a Zenith, I would say that, yeah, there's a good chance it probably turned on and produced some kind of picture just because of the quality of the parts, but not with a Philco. And you can tell that there's no evidence that these pots have even been cleaned or sprayed with any kind of cleaner. They're dry and dusty as can be. I'm interested in this thing though. I wonder what... Okay, well, seeing the condition of this, I believe the first thing I want to do is just baseline it and assume that it didn't work and check the CRT. And if the CRT checks out, then we'll progress from there. Now these use a 2.5 filament, yeah, 2.5 filament CRT, so I'll have to be mindful of that. Here's looking in the CRT area. Not quite sure what the number is of this thing. Well, not knowing the number, but knowing that it's a 21-inch tube, I went through all the 21s, and there's only two of them that are 2.68 volts, and one of them's a 21 EVP4, which is B4, socket B, bias 4, and there is one more. There's an EAP4, which is 2.35 volts, which is B4 also. Wait, that's 2.35 and 2.68. Boy, Philco, just brilliant, man. I'm going to, I got this down at 1 volt. And we're gonna put this on B. And we're going to go socket 4, and we'll see what we get. Alright, here we go. I'll turn that all the way up. We'll do the filament set. 2 point... We'll just stay real low at this. You can see they even got a red mark there for the 2.35 and the 2.68. That's pretty interesting. So let's see. Shorts. No shorts. Well, that was interesting. See, let's go to cutoff. It's actually got some cutoff. Well, hey, it's not going to produce a museum quality picture, but it's working its way up. It's working its way up. So now the next concern would be this thing, and of course I would like to say that that's probably not bad. I'd like to guess that that's not bad. I guess we could put a cathode current meter on it and see what kind of cathode current we're drawing. But the problem is with these things just short. These things just short. They go to 0 ohms, and they'll prevent it from working. And the big problem with these TVs is the serviceability of this thing. You can see that you can't get to the circuit board from here. It's mandatory that to do this right, you have to disconnect all of these wires, or at least from the top here. I don't know about all of this down here, but you have to disconnect these to drop this board down. I mean, what a pain in the ass. And then I don't know if there's any in here, but what I would be tempted to do is just to cut them off at the top and tack them on. I know it's not right. I know it's not the popular way of doing things, but you know, unless you're going to get paid for your time, then well, this one right here, that'd be interesting to try and cut that off the top and tack one on. So it's coming up, and I'm only at the low. I'm only at the low, the 2.3 volts. So it's possibly the CRT is good, or not good, but you know, will produce a good picture. So is it possible that this thing worked before it was shipped? Yes, it is possible. It's highly unlikely, but it's possible. And the reason why I say that is a lot of times what I've noticed is with capacitors and that, you take an old TV that hasn't been run in a long time, in say 20 or 30 years, and you plug it in and turn it on, and it works. It works for about 10 minutes, and then the capacitor's short. So is it possible that it worked? Yeah, it's possible. Is it likely? Not really. Has it been restored? Hell no. It's as virgin gets. And it might be, there we go with the question marks again. It might be a low hour TV. And it's very possible that if it is a low hour set and everything is good in here except the capacitors, it was probably worth what he paid for it. But again, he bought it thinking it was restored. Now I'm gonna have to formulate, you know, I'm gonna have to formulate a price to do this, because this is not something that you can do in 15 minutes. This is several hours worth of work. Just to cut these off the top, I'm going to have to formulate a price. And it might be, it might be a low hour TV. And it's very possible that if it is a low hour set and everything is good in here except the capacitors, it was probably worth what he paid for it. But again, he bought it thinking it was restored. Now I'm going to have to formulate a price to do this, because this is not something that you can do in 15 minutes. This is several hours worth of work. Just to cut these off the top, and change them. I mean, I don't even know about that one, but to cut them off the top and change them, and these, forget the electrolytics and anything else, but just to do the cap changer is probably 3 to 4 hours worth of solid work. And even if you figure a poverty wage labor rate of $30 an hour, you're still looking at over $100. So I don't know. There you have it. There's the beginning of this, and we'll see what the next step is. Okay, we got our favorite watt meter. Take a look at the input current draw. We got a milliamp meter, and we got it just tied into the plate there. I don't recommend anyone do this. You're supposed to measure the cathode current, even though the plate current's more accurate, but this is not nearly as safe with 6,000 volt pulses or whatever on these wires, but I've never been one for safety. Huh. Well, what are we doing? What are we doing wrong here? 127 watts, and sure enough, nobody's home here. Well, is the damper open? I imagine this is the damper right here. This is a voltage you can measure with the cap off the tube. If you try and measure this with the cap on the tube, you won't have a meter anymore. It's 283 volts. Look at this. This is actually an original Philco tube, and it doesn't look fried. I wonder if it's just loose in the socket. Let's try this again. Alright, this thing moves up about 5 milliamps. I'm moving the tube around right now, and there's nothing going on there. Now let's see. Boy, is that sloppy or what? Look at that. Look at how close that is. Really? Look at that. I tell you, Philco doesn't cease to amaze me. I mean, this thing is the Hyundai Excel of TVs. So we should have one of these up around, I have a feeling this is the screen, which should have a bias on it of about 110 volts or something, and it's sitting at 0. I'm sorry, 0.09. And this might be the cathode. Not the cathode, the control grid. And it's 35, and it should be negative 35. But it might be positive if the screen doesn't have any voltage on it. And then 2 of them are the filament. I wonder what this one is. That one's 0.1 and that one's 0. So we're definitely missing our screen voltage here. And that would cause this not to work. And I wonder if this capacitor is shorted, but then you would think the resistor would be smoking. I need to get a schematic on this. Here's a look at the schematic. And I've been confusing the screen, which is this one right here, with the grid, which is that one right there. Actually, a screen is a grid, but we'll call this a control grid. We'll call that the screen. And this one should be negative 45 volts. This one should be 175 volts. I didn't see any pins there with 100 and anything on them, so this is pin 4. And unless this voltage is here, this tube won't operate. And I don't believe that'll be in a negative voltage without this voltage. So it comes down here to a 2.7K at 1 watt. Then we got a, is that 10,000 picofarad, 0.01, I think so, 0.1, something like that. And then we got a 3.9K, and then it comes to a width pot here, which is a 56K here, and this goes to the 280 volt source that we know is there because we're seeing it on the plate. But okay, so we gotta check this and see if it's open, see if that may be shorted, see if that's open, and check that and see maybe if that pot is not conducting for some reason. Well, this is interesting. It shows R5 here, which is that pot up at the top. Now, is this that thing? Because this chassis is turned in the set. As you can see, this is the board. It's on the bottom. Is this that thing that had electrical tape on it? I was going, what is this? Let's take a look. Okay, here's that pot. It's up at the top of the... So we'll start by checking the voltage there. And we have 300 volts there. See what we got over here. Got 323 volts there. Let's see what we got on the resistor. We got 300 and, well, let it warm up and stabilize. Isn't this supposed to be 280 volts? Let's see. I'm sure this is... And it is 284. And we have 166 going down, supposedly going down to the tube, and 164 on the other side. Okay, I believe it was pin 6, which is this 0.1, and it's still showing negative 0.2 volts. Let me trace that wire. Alright, I've been being a idiot all along. This is pin 4. This is supposed to be the screen voltage. And you can see it's way too low. Which is kind of interesting. That would indicate the tube is good, but it's just maybe not getting a oscillator signal to it. Okay, this is the grid, a control grid. This should be negative 45 volts. This other one right here that this capacitor is attached to right there, the orange wire, that's nothing. That's pin 6. They're just using that as a terminal strip. Well, I'm moving the tubes around right now. Alright, well that's not good. Let's see if there's any... No AC there. Alright, so usually when that's the case it will burn up the tube. But the oscillator is not running, so that would be the first thing to play with. Alright, well most of this thing is inside. There's no negative 45 volts and no AC here. Most of this thing is inside this couplet right here. But, see, 390, that should be a disc. 0.0039, that would be a bumblebee. And anything from here on back shouldn't really matter, so I guess we'll take a... Unfortunately, I can't get to my schematics right now and I don't have a printer, so maybe the thing to do is to pull this 6CG7 out and measure some voltages. Although I don't even want to, you know, these tube sockets in these sets fail too, so I'm reluctant to even do that. Oh, here's a tube that's not original. See, that's what I mean, and I hope I don't break these crappy tube sockets. Look at how crappy that thing is. They snap right where the wire loops over. Alright, we got our test adapter on there. Pin 1 and pin 6 are supposed to be 175 volts. And pin 1 is 0 volts. And let's see, 2, 3, 4, 1, 2, 3, 4, 5, 6. And that one's not reading anything. What am I doing wrong here? Oh, what am I doing wrong? I'm measuring it with this stupid meter on AC. So, okay, that's pin 6. It's supposed to be 175 volts. It's measuring 48 volts. That's not going to work. So where's pin 1? Pin 1 is 0. Which is quite probable, and of course there is a capacitor in the couplet. Pin 1 is 0. Am I on pin 1 here? Pin 1, yes. Pin 1, 3, 4, 2, 1. Okay. Real deep. So that would make sense that the other one would be... And that's the couplet right there. And it's kind of weird that it was bent down like that, like maybe someone was trying to probe it. Huh. Alright, well I've already filled the disk up and had to delete some stuff, so I'm getting... Okay, so basically this is supposed to be 175. It dropped down to like 40 volts. No, this one was 40 volts. This one, pin 1, had dropped down to nothing. So it goes through the coil and then to a 15K 2-watt resistor and then to the pin 1. Now the tube socket could be bad. Okay, there's our coil. And that would be 1.5K, right? Brown, green, red. That looks like brown, green, red to me. Alright, let's measure it. It sure does look like it would be going to where pin 1 is if you look at it there straight down. Okay, what is going on with this thing? I got nothing here, but I got 282 volts right there. What is going on with this thing? Is the tube socket broken? So what do I have over here on pin 6? 2, 3, 4, 5, 6. 116 volts, but I got nothing here on pin 1. Nothing. Oh, I'm moving the tube around. Okay, I'm back on the horizontal output tube, and look at that. When I move the I got that thing pulled way down, I get negative 55 volts here. And do we have a raster at all? There it went away again. Come on, baby, just stay. Jeez. Alright, so usually remember if this thing loses horizontal drive, it'll burn the output tube out. So maybe we need to check the output tube real quick. Alright, let me use my brain here. Well, what are we doing? Are we getting hot? Alright, let me just use my brain here and just do something like that. See if it works. There we go. Well, it started oscillating for a minute. Okay, what's going on? Okay, let's try this again. There we go, negative 40 now. This is a new 12 DQ6, by the way. So that's it. It should have high voltage, I would think. Alright, what is going on with this thing? If I push on the tube, I got the adapter off, it definitely has got a bad tube socket. That's not pushing on it, that's pushing on it. So definitely got a bad tube socket, but even if I push on it, I still am not getting high voltage. Now I'm back on the screen again, and with the cap off, I'm getting 123 volts. And with the cap on, I'm getting 132. I should probably be getting about 123 and 175. So that would indicate there's not enough current coming down this line. So is it possible that the damper is fried? This is the damper, I would assume, right here. Good question. Okay, here's a damper. This is a 12D4, something like that. 12D4, dead as a rock. Let's go up to 15 volts. Thing is dead. Let's see, what is this? 12DQ6. Yeah, I would say this ain't gonna cut it. That's back down to well, 11 to 14 volts, and it's a 12 volt tube. This thing is done. Okay, here's a horizontal output tube, the 12. It's a 12DQ6. Let's go down to 9 to 10 volts. Okay, let's go down to 7 to 8 volts. This is a good strong tube right here. A 12 volt tube on the 7 to 8 volt scale. This is a good tube. Okay, so the tube which was right there on top is this one, which was the 12D4 is shot. And that would make sense because when this tube wasn't oscillating and putting out, usually what will happen is this will red plate, but remember this tube gets its power through this tube. So I guess this was the stronger of the two tubes, and this is the one that red plated and burned up. So I need to get a 12D4 before we proceed, and right now I don't have access to a lot of my equipment. It's in a building that I'm having fumigated, so I won't have access for a few days. If it works, if we get high voltage after that, then there's no other option than that circuit board has to come off of there to change that tube socket. That's a big job. And if we're going to pull it off, we might as well change the capacitors and spot check the resistors too. So, yeah. Let's all listen to this airplane, or this helicopter. So at least we know where we stand. It looks like we know what happened. It's all guessing, but hey, we can prove it by getting another one of these tubes and moving forward. Anyway, I might make this part 1, or I might just, I don't know what I'm going to do right now. You will find out. I took a look at my spreadsheets, and I do have a 12D4. However, like I said, I can't access it because the area is being fumigated, so maybe we'll get back to this on Sunday. Today is Thursday, and we'll pop it in there and see what we get. Back to the Philco Predicta Pedestal black and white set. It was established in the first part of this video that through a long diagnostic process, getting lost in several turns, that the main problem we're facing with, besides all original capacitors and resistors and everything else, is that pin 1, the power to the plate of the horizontal oscillator tube, is not there because of a bad tube socket. And you can see where I've used a jumper to my test socket to provide that plate voltage from that 1 watt, 2 watt resistor down there. And where I last left off, the damper tube right there is dead. Now, in the beginning of this video, one of the first things I did was I unplugged this and I measured to see if there was voltage here, and there was. And you might be saying, well, if the tube is bad, why is there voltage there? Well, there's voltage there with no load. But as soon as you load this down, draw 5 or 10 milliamps through it, because that tube is very weak, that voltage goes away. And we really can't measure that, because you never measure this with it hooked up, or else you will burn up whatever you're trying to measure that with. There's really high voltage pulses here, 5,000 or 6,000 volt pulses, and they'll destroy just about any meter out there. So I got a new 12D4. We're going to pop it in. We're going to watch the plate current, and we're going to see what happens. All right, the tubes are heating up. It's looking better already. And that seems a little bit excessive to me. See what happens if I disconnect the horizontal oscillator. Yeah, the oscillator's not running. That was too high. Okay, it's still this tube socket. See if I can get this all in frame here. Watch what happens when I move this tube. So this tube socket's got to be changed. It's just broken in multiple spots. And look at this. Still no audio. Still no audio on a shrunk horizontal raster, but let's check into that. Alright, I got it hooked up to my set-top box. Let's see what we can... Well, Not much of a picture, and this is probably what you would expect with all those old capacitors in there, but you can see that the flyback is working. You can see that the CRT is good. You can see that there is potential. Now the question is, just to be straight up, do you want to spend the money to make it right? Did this thing ever work in the seller's possession? No. Flat out no. There's another problem that's causing the sound not to work besides all this other stuff. So, no. That's just hooked up to the converter box. And just to throw this in, I was told by someone who's restored several of these, charge at least 20 hours to do what needs to be done, because to get that board out of there and recap it and replace the tube socket and then the caps on the back, you're looking at a minimum of 20 hours worth of labor, and then you still got capacitors inside here that need to be changed. Now I was just wondering if maybe we got another tube socket, that's why the audio doesn't work. Now watch this. I had to adjust the fine tuning a little bit.
Don't be broke. Use the equity in your vehicle to get cash today. Car title. Fast cash to low. Payments every day.
Welcome home. That's right. This could be your new home. If you enter the 6th annual Reindeer Cycle, a benefit for Special Olympics, Southern California, valued at $5.5 million. This 5-bedroom, 5-bath Hidden Hills home is being raffled off. There are over 1,600 prizes. The odds of winning are 1 in 50. And the earlier you enter, the more chances you have to win. Call 800-816-6108 and get your ticket now.